Course 3, Lesson 99. We are looking at inverse variation here. So this is similar to what we've talked about with direct variation, but kind of just the opposite. We're going to use a lot of the same terms that we've used before, but with inverse variation. So we've looked at direct variation before and said that y equals kx is the original equation, which we can then find our constant k by doing the quotient y divided by x. And when we look at direct variation, they kind of go together. As one increases, the other increases. Whereas with indirect variation, or I often call it just inverse variation, y is still the constant, but instead of finding the constant using a quotient, we use the product. And we can say that the equation for our inverse variation is y is equal to k divided by x. So we can see that they are just a little bit different from each other, and with inverse variation, as one increases, the other decreases. So with inverse variation, we find our constant by using a product. With direct variation, we find k by using a quotient. All right, so let's look at a situation here. Sharon bakes a loaf of bread each week. Each friend gets an equal portion. If there are a lot of friends at her house, each person gets a small piece. If there are a couple of friends at the house, each friend gets a larger piece. Is this direct or indirect variation? So let's make a table and see if, as we increase the number of people, what happens to how much bread they each get. So we'll say this is the number of people, n, and this is how much bread they get. We'll say, the portion as far as the fraction that they get of bread. So if it's just Sharon over, well, she gets the whole bread. If there are 2 people over, they each get a half. If there's 3 people, they each get a third. 4 people, 1/4. And you start to see the pattern here. And what we see is that as we increase the number of people, the amount of bread that each person gets decreases. So this is indirect variation. We can also see that if we look at the product of these two variables, 1 times 1 is always equal to 1. 2 times 1/2 is equal to 1. 3 times 1/3 is equal to 1. 4 times 1/4 is equal to 1. That product is always constant. Okay? And we can kind of see this because we have a constant amount of bread that gets divided into how many people. So we can see this is an example of inverse variation. Let's try this one. Sam travels 120 miles to visit his friend. If he averages 60 miles per hour, then the trip takes 2 hours. What's the constant in this problem? Well, it seems that the constant in this problem is actually how many miles it takes to get to this person's house. So we would say the constant is 120 miles because it looks like his rate is not always going to be constant. So we're going to create a chart with the possible speeds and times it would take him. Okay, and we're going to prove then that these are inversely proportional. So if I have x, the speed, y is going to be the hours. Okay, so this is my miles per hour, and this is how many hours it's going to take. So let's start really small. Let's say he's going 10 miles per hour. Well, then that means it's going to take him 12 hours to get there. Maybe he's going 12 miles per hour. Well, that means it's going to take him 10 hours. Maybe he's going 20 miles per hour. Well, then it's going to take him 6 hours. Maybe he's going 30 miles per hour. That's going to take 4 hours. 40 miles per hour is going to take 3 hours. 60 miles per hour is going to take 2 hours. And let's say he's going a whopping 120 miles per hour. That means that it's going to take him 1 hour. Okay? So we can see how as we increase the miles per hour, the hours it takes him decreases. And so we can see, yes, these are inversely proportional because all of those products from x to y all equal 120 because that is our constant. We have a constant 120 miles to drive. So if we were to go ahead and graph this take all of those x's and y's and graph them, it would look something like this. Okay, so we have all of those different rates here, and we can see, all right, if I graph 2 miles per hour, it's going to be 60 hours. 4 miles per hour, it's going to be 30 hours. 20 hours, and so on and so forth. We have all of these points, and you can see, very unlike a direct variation, it's not a straight line at all, and it definitely doesn't go through the origin. So this is its own thing. Inverse variation looks very different from direct variation as well. All right, different situation. Robots are programmed to assemble parts. The number of robots working n and the amount of time it takes to assemble the products are inversely proportional. If it takes 10 robots 8 hours to assemble a truckload of products, how long would it take 20 robots? First, find the constant, and then we're going to plug in to find the time. So let's set up a little table here, and we are saying I have n amount of robots for t amount of time. And in this case, what we know is we have 10 robots for 8 hours to assemble this truckload of parts. So what we want to know is how many. If I have 20 robots, how many hours would it take? Well, what we can do is actually plug in to find my constant and say n and t act like x and y. So I could say 10 times 8 is going to give me my constant. So it looks like my constant is 80. Well, now that I know my constant, I can say if I have x and y, they have to equal 80. Every single time in this situation, they have to equal 80. So if I now know that x is 20, I have 20 robots, I can see that y would have to be 4. So it takes 4 hours to assemble those products with 20 robots. You can see how as we double the number of robots, it decreases the time by a half. All right, so once again, I'll say that again. In the example, we see that doubling the number of robots reduces the working time to half the original time. What about this? If the number of robots were tripled, what fraction of the original time would the robots take to complete the job? So once again, if I have n and t, we had 10 robots taking 8 hours, 20 robots taking 4 hours. Maybe we have 30 robots. And so let's plug it in. We have 30 times y is equal to 80. Well, that would mean y is equal to 8/3, meaning I am taking 1/3 of the original time. If I triple the amount of robots, it's 1/3 of the time. It works together like that. Okay, so are these inverse or direct variation? Well, remember that if we have a quotient finding k, that is direct variation. If we have a product finding k, that is inverse variation. Okay, and how about these graphs? Straight line versus a curved line. Well, straight line gives us direct variation when it goes through the origin, and this curved line is inverse variation. Okay. All right, so just a couple more examples here for you. Determine if these are inversely proportional, and if they are, how do you know? Well, if we look at the first table, m and n, I am increasing m, and my n decreases. So we're on the right track. The question now is, do we have a constant product? Well, this constant product gives me 3, this one gives me 4, and this one gives me 3, which means this is not inverse variation. On my second example, we are increasing while the other is decreasing, and it looks like my product is 6, this is 6, and this is 6. So yes, this is inverse variation, and I could even write an equation by saying y is equal to my constant 6 divided by x. Or you could write it like we've done in the past, xy is equal to 6. Both of those are the same. All right, it takes 3 people 5 hours to complete a job. How long would it take 5 people to complete the same job? So if we have this xy, if x is my people and y is my hours, 3 people is 5 hours. So 5 people is how many hours? Well, if we know, and this type of situation is inverse variation, our constant here is a product of 15. So if this is going to be a product of 15, it must mean that this is 3 hours. The volume and air pressure in a balloon is inversely proportional. if the balloon is squeezed to half its original volume, what factor does the air pressure increase? So let's try this out. If I have a volume and an air pressure, okay, and let's say my volume was 100, and I'm just going to make up some information, and my pressure was 50, okay? If I have these, okay, volume is 100, and I cut that into half. So now this is 50. What happens to the pressure? Well, with inverse variation, if I decrease, the other should increase, okay? And if I half one of them, I have to double the other, which means this is going to be 100. And we can prove that using our constants, but maybe to show you again a different volume and pressure, maybe we have 8 and we have, I don't know, 18. Doesn't really matter. If I cut that in half, this one is going to have to double to 36, okay? Because I have to keep that constant, that product the same. So if I half something, I have to double the other. All right, well, I hope this is helpful for your homework and for studying.